Hi, my name is Frank Marchis. I'm a senior researcher at the SETI Institute and the chief scientific officer of Unistellar. So, first you may wonder, what is the SETI Institute? The SETI Institute is a non-profit organization, and the goal of the institute is to find life, any type of life in the universe. Recently, we did a partnership with Unistellar, a company located in France, which developed this type of small telescopes, and you have received one of them. This is what we call the Enhanced Vision Telescope, the eVscope.
Your Unistellar eVscope is an easy-to-use digital smart telescope. It can be set up in less than a minute. All you do is pop open the tripod, put your eVscope on it, press the on button, connect to it wirelessly with your smartphone or tablet using Unistellar app, press a couple controls, and you're viewing the universe.
And using the eVscope, you will be able to enjoy the dark sky, see galaxy nebulae from cities, but as well in the countryside. And you can also participate to citizen science programs, meaning that you can help the SETI Institute and its researcher to do research.
So the entire eVscope fits into this backpack. So the telescope, the tripod, all the charging equipment can be stored in this backpack, which make it really easy to take around campus, different observing locations, and it also makes it really good to share among students in the classroom.
Light comes into it, just like a normal telescope, bounces off the mirror, but it's collected in a digital sensor at the top. Then that digital information goes in the computer and then is relayed wirelessly to the app on your phone. You can then press a button called Enhanced Vision. This is where the real magic of the telescope is, except it's not magic, it's science. And what it does, it takes the light pollution out of our light polluted skies and stacks the images so it collects more and more light, like a picture of a long exposure, so you can see farther. That way you can see deep space objects, such as star clusters, nebulae, and galaxies.
Here we're taking a look at a planetary nebula called the Dumbbell Nebula, taken with an eVscope. The Dumbbell Nebula is located about 1,400 light years from Earth, and a planetary nebula forms when stars ranging from 1 to 8 times the mass of our sun die and eject their outer layers, creating the gas we see in the image, that also leave behind a white dwarf at its center. Here we're taking a look at the Triangulum Galaxy, also called M33, taken with an eVscope. The Triangulum Galaxy is located 2.7 million light years from Earth, and although the Triangulum Galaxy is considered to be one of the smallest spiral galaxies in our local group of galaxies, one can actually see the Triangulum Galaxy with the naked eye in perfect observing conditions.
Your eVscope also has the capability of collecting research quality astronomical data. You can participate in citizen science observations with our global community of over 7,000 Unistellar eVscope users. And you can investigate scientific events such as Planetary Defense, asteroid occultations, and exoplanets. This way, you can learn science in your science class by actually doing science.
Hi, I'm Joe, Planetary Defense Lead for the Unistellar Network. We develop a planetary defense program to track near-Earth objects. With the observation of our network, we'll find the orbit of near-Earth asteroids, space debris, space probes like solar orbiters. We series their position to the minor planet center, and we also build 3D model of near-Earth asteroids.
Another aspect of the citizen science that we're doing with the eVscopes are asteroid occultations. So these are observations where we put the eVscope in the shadow cast by an asteroid as it crosses in front of a distant star. Now these happen every day and all over the world, and we're particularly interested in occultations by the Jupiter Trojan asteroids, which are being visited by NASA's Lucy mission. This is the first mission to ever go to the Trojan asteroids. It's going to be studying these objects, which are essentially relics from the early days of planet formation in our solar system. And our occultation observations are going to measure the shape and position of the asteroids, which is directly useful information for NASA's mission.
In our exoplanet program, you can use the eVscope to observe stars hundreds of light years away and see their planets cause small eclipses of those stars, which we call exoplanet transits. You can actually measure the presence of other worlds so far away. Some are very different from many planets we have in our solar system, and many are newly discovered, so your observations can help teach us new things about them. There's still a lot to learn about exoplanets, including which ones may be home to life, and you never know. The science you can do with an eVscope, even if it seems small, may help us one day in our search for extraterrestrial life.
By participating in our citizen science observations, you're going to have fun. But you're also going to take ownership and learn your astronomy concepts at a much deeper level.
So, now that you have access to an easy-to-use, powerful telescope, we hope you'll take advantage of it. Take some object that you learned about in class and go look at it for yourself. Or go look at something completely different and then compare the two. This is something that Kendras Story has done with her students at Metropolitan Community College in Omaha, Nebraska.
Hi, my name is Dr. Kendras Story, and I teach physics and astronomy at Metropolitan Community College in Omaha, Nebraska. I was invited to test the eVscope and incorporate it into my teaching. I started by observing in my backyard. Even though I had light-polluted skies, within a few minutes of observing some of my favorite deep sky objects, I had the best live views of them I'd ever seen. I've been able to have a remote telescope observing session for my students, and if we were able to meet in person, the students could connect to the telescope's Wi-Fi and use their own mobile devices. They could download the photos and then share them widely with friends and family. This technology will allow my community college astronomy students to participate in real scientific studies such as asteroid occultations and exoplanet transits.
We also hope you can spread the love a bit. Maybe help your school host a star party. Invite your friends and family to see the night sky in ways that maybe they never have before.
Some students might actually want to lead their own citizen science investigations. We may be able to fund you to actually present what you discover at a local, regional, or national science conference. The universe is vast, and there's so much that we just don't know about. But now, you're an explorer. You can't wait to find out what you discover.